March 15, 1943. Henderson Field, Guadalcanal, Solomon Islands. Oberleutnant Karl Schneider stood in the shade of a palm tree, his Luftwaffe uniform darkened with sweat, watching American construction crews work on the airstrip his own engineers had abandoned 6 months earlier. He had been shot down 3 days prior during a reconnaissance mission, captured by Marine raiders, and was now awaiting transport to a prisoner of war facility. What he witnessed in those 3 days would haunt him for the rest of his life, not because of brutality or deprivation, but because of what it revealed about the inevitable outcome of the war. American construction battalions, wearing dungarees instead of combat uniforms, were transforming the crude airfield into a modern military installation at a pace that defied everything Schneider had learned about engineering, logistics, and the limitations of men working in tropical heat. The runway his Luftwaffe comrades had bombed repeatedly was being repaired faster than they could damage it. New taxiways appeared overnight, revetments for aircraft rose from the jungle, fuel storage facilities materialized where jungle had stood the previous morning. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schneider was not witnessing magic, though it seemed that way to his trained engineer's eye. He was witnessing the United States Navy Construction Battalions, the Seabees, demonstrating a form of warfare the Axis powers had never contemplated, the ability to project not just military force, but industrial capacity itself, across thousands of miles of ocean and reconstruct civilization in the midst of jungle and coral. This was the weapon that would decide the war, though few understood it yet. The origins of the Seabees lay not in military planning, but in the chaos of America's entry into World War II. On December 7, 1941, Japanese aircraft struck Pearl Harbor, destroying battleships and killing over 2,000 Americans. Within days, the United States declared war on Japan and Germany. The military mobilization that followed exposed a critical vulnerability in American war planning. The United States Navy possessed no dedicated construction units. When Marine and Army forces needed airfields built, roads constructed, or harbors dredged, the Navy relied on civilian contractors protected by whatever combat troops could be spared. This system had worked adequately in peacetime or in operations conducted with overwhelming force. It failed catastrophically under combat conditions. The Wake Island disaster demonstrated the problem with brutal clarity. In December 1941, civilian construction workers employed by Morrison Knudsen Company were building airfield facilities on Wake Island when Japanese forces attacked. The civilians had no military status, carried no weapons, and possessed no legal protections under the laws of war. When Wake fell after heroic resistance by the Marine garrison, approximately 1,200 civilian workers became prisoners of war. The Japanese, viewing them as non-combatants engaged in military construction, executed 98 of them in October 1943 for attempting to mark messages on a coral rock. The remaining civilians endured years of brutal captivity, many dying from disease, malnutrition, and abuse. Rear Admiral Ben Morrell, chief of the Navy's Bureau of Yards and Docks, recognized that the United States needed military construction units that could fight if attacked, possessed military status under the Geneva Convention, and could operate in combat zones without the legal and moral complexities that endangered civilian contractors. In a memorandum to the Chief of Naval Operations dated December 28, 1941, preserved in the National Archives, Morrell wrote, "The Bureau respectfully submits that the present system of employing civilian contractors in combat zones places American workers in untenable positions, violates the spirit, if not the letter of international law, and fails to provide adequate protection for construction personnel. The Bureau recommends immediate authorization for a naval construction force with military rank, training in combat, and the status of combatants under the laws of war." The proposal faced immediate resistance. The Marine Corps questioned whether construction workers could be trained as soldiers. The Army objected to Navy encroachment on what it viewed as ground force responsibilities. Budget-conscious officials balked at the cost of creating an entirely new military branch. But Admiral Ernest King, Commander-in-Chief of the United States Fleet, understood the strategic necessity. On January 5, 1942, King authorized the formation of the Naval Construction Battalions, with Morel serving as their commanding officer. The name Construction Battalions was immediately shortened in military fashion to Seabee, pronounced phonetically as Seabee. Within days, recruiters were seeking men with construction experience, engineering skills, and the physical ability to perform heavy labor in tropical heat. The recruitment standards differed dramatically from those of other military services. The Seabees wanted men who knew how to operate bulldozers, pour concrete, weld steel, repair engines, survey land, and improvise solutions to unexpected problems. Combat experience was optional. The ability to build a bridge, install electrical systems, or operate heavy machinery was mandatory. The age requirements reflected this priority. While the Marines and Army sought young men in peak physical condition, the Seabees accepted men up to 50 years old if they possessed critical skills. Master carpenters, heavy equipment operators, and experienced construction foremen found themselves wearing Navy uniforms, at ages when other services would have rejected them. This created construction battalions staffed by men who had spent decades in civilian trades, who understood soil mechanics and load-bearing calculations, who knew the difference between structural and non-structural concrete, and who could look at terrain and visualize drainage patterns, road alignments, and optimal building sites. The 1st Seabee Battalion, designated the 1st Naval Construction Battalion, was authorized on January 5, 1942. By March, recruitment was underway across the United States. The Navy established its principal Seabee training center at Camp Allen, near Norfolk, Virginia, expanding it rapidly as recruitment accelerated. Additional training facilities opened at Camp Peary, Virginia, Camp Endicott, Rhode Island, Port Hueneme, California, and Gulfport, Mississippi. The training program reflected the dual nature of Seabee responsibilities. Men learned military discipline, weapons handling, and small unit tactics, while simultaneously receiving instruction in military construction techniques, equipment operation, and field engineering. A typical Seabee battalion consisted of approximately 1,000 men organized into a headquarters company and 4 construction companies. Each company possessed specialists in carpentry, concrete work, electrical installation, equipment operation, explosives handling, metalwork, and surveying. The equipment assigned to each battalion represented a complete mobile construction company: bulldozers, graders, power shovels, cranes, concrete mixers, generators, welding units, carpentry shops, and specialized vehicles for every construction task imaginable. The organizational structure emphasized flexibility and self-sufficiency. Unlike conventional military units that relied on extensive supply chains, Seabee battalions carried their own tools, spare parts, and repair facilities. They could maintain and repair their equipment in the field, improvise replacements for damaged machinery, and continue operations even when cut off from external support. This self-reliance would prove crucial in the island campaigns of the Pacific, where supply lines stretched across thousands of miles of ocean patrolled by enemy submarines and aircraft. The strategic situation in early 1943 demanded rapid deployment of Seabee units to the Pacific theater. Japanese forces had conquered a vast empire stretching from Burma to the Solomon Islands. American strategy for reclaiming the Pacific required island hopping, seizing strategic islands and converting them into air and naval bases that could support further advances. This strategy depended absolutely on the ability to construct airfields rapidly on captured territory. An island without an airfield was merely a piece of coral. An island with an operational airfield became an unsinkable aircraft carrier. Guadalcanal exemplified both the necessity and the challenge of this strategy. The island, part of the Solomon chain, had been invaded by Japanese forces in May 1942. Japanese engineers immediately began constructing an airfield on the northern coast near Lunga Point. The airfield, once operational, would threaten Allied supply lines to Australia and provide a base for Japanese bombers to strike targets across the South Pacific. The United States could not permit this. On August 7, 1942, Marines of the 1st Marine Division stormed ashore at Guadalcanal in Operation Watchtower. The landing achieved tactical surprise. Japanese construction workers fled into the jungle, abandoning equipment, supplies, and a partially completed airfield. The Marines secured the perimeter and immediately recognized the strategic importance of completing the airfield. But the 1st Marine Division possessed minimal construction equipment and no dedicated construction units. The Marines improvised using captured Japanese equipment and whatever tools they could scrounge. Working under threat of Japanese air attack and lacking proper engineering equipment, Marines managed to complete a crude operational airstrip by August 17th. They named it Henderson Field after Major Lofton Henderson, a Marine aviator killed at the Battle of Midway. Henderson Field became the most fought-over piece of real estate in the Pacific War. Japanese forces launched repeated ground assaults attempting to recapture it. The Imperial Japanese Navy bombarded it with battleship guns. Japanese bombers struck it daily, yet Henderson Field remained operational because of constant heroic repair efforts by Marines and the 1st Seabee units to arrive on Guadalcanal. The 6th Naval Construction Battalion landed on Guadalcanal on September 1st, 1942, bringing the first dedicated construction unit to the island. The battalion consisted of 32 officers and 1,079 enlisted men equipped with bulldozers, graders, and construction equipment that Marines could never have obtained through normal supply channels. The 6th Battalion's assignment was straightforward but nearly impossible. Maintain Henderson Field in operational condition despite daily Japanese bombing. Extend the runway to accommodate larger aircraft. Build taxiways, revetments, and support facilities. Construct roads connecting the airfield to supply dumps and defensive positions. And accomplish all of this while living in foxholes, working under air attack, and enduring tropical diseases that were killing or incapacitating men at alarming rates. The work proceeded under conditions that would have caused civilian contractors to abandon the project. Japanese bombers struck Henderson Field almost daily, cratering the runway and destroying equipment. Seabees developed a grimly efficient routine, hiding their equipment in the jungle during air raids, then rushing back to the runway immediately after bombs stopped falling. Craters were filled, graded, and compacted within hours. Aircraft that had taken off before the raid landed afterward on runways that bore fresh scars, but remained operational. The tropical environment presented challenges as severe as enemy action. Guadalcanal receives over 200 inches of rain annually. The airfield, built on flat ground near the coast, flooded regularly. Drainage ditches dug one day, filled with silt the next. Coral dust generated by construction equipment mixed with rain to create a choking mud that clogged machinery and made every surface treacherously slippery. Malaria infected nearly every man on the island. Dysentery, dengue fever, and fungal infections further degraded the workforce. The Seabees adapted. When drainage ditches filled with silt, they installed culverts made from salvaged Japanese fuel drums cut and welded into pipes. When mud made the runway unusable, they crushed coral and compacted it to create a surface that could support aircraft in wet conditions. When malaria incapacitated a third of the battalion, those still able to work doubled their shifts. The battalion's war diary, preserved in National Archives records, documented the scale of operations. In October 1942, the 6th Battalion repaired Henderson Field after 23 separate air raids. They maintained continuous operations of the runway, extended it by 600 feet, constructed 23 aircraft revetments, built 14 miles of roads, installed fuel storage facilities with capacity for 250,000 gallons of aviation gasoline, and erected warehouses, workshops, and living quarters for support personnel. The human cost was substantial. The battalion suffered casualties from air raids, naval bombardment, and ground combat when Japanese forces penetrated the defensive perimeter. Disease claimed more men than enemy action. By January 1943, when the 6th Battalion was relieved, over 40% of its personnel had been evacuated due to wounds, disease, or mental breakdown from the relentless strain. Yet Henderson Field remained operational. The airfield that Japanese engineers had begun and abandoned became the unsinkable aircraft carrier that turned the tide in the Solomon Islands campaign. By March 1943, when Oberleutnant Schneider found himself captive on Guadalcanal, the island bore little resemblance to the desperate battlefield of 6 months earlier. The 6th Naval Construction Battalion had been relieved by the 14th Naval Construction Battalion. Additional Seabee units had arrived, bringing the total construction force to over 3,000 men. Henderson Field had evolved from a crude airstrip into a major airbase with multiple runways, extensive taxiways, hardened aircraft revetments, fuel farms, ammunition, storage bunkers, repair facilities, and all the infrastructure required for continuous large-scale air operations. Schneider, trained as an engineer at the Technische Hochschule in Berlin, possessed the technical knowledge to appreciate what he was witnessing. The 14th Battalion was constructing a second runway parallel to Henderson Field's main strip. The work proceeded with mechanized efficiency that German military construction units could not match. American bulldozers, far larger than anything in Luftwaffe engineering inventory, pushed jungle aside in straight swaths. Graders followed, leveling and shaping the surface. Rollers compacted the coral base. Dump trucks delivered crushed coral in continuous streams. The equipment worked in orchestrated sequence, each machine performing its specialized task, the entire operation flowing like a well-rehearsed industrial process. The scale of equipment deployment impressed Schneider more than any individual machine. He counted 16 bulldozers working simultaneously on the runway project. More bulldozers operated nearby on road construction. Cranes, lifted structural, steel for hangars. Power shovels excavated drainage ditches. Concrete mixers produced material for revetment walls. The Americans had transported an entire industrial infrastructure across 5,000 miles of ocean and reassembled it on a tropical island. But the equipment alone did not explain the pace of work. Schneider observed the men operating the machinery and performing manual labor. They worked with the casual competence of experienced tradesmen rather than the rigid discipline of military engineers. Bulldozer operators maneuvered their machines with precision, shaving earth to exact grades without constant supervision. Carpenters erected formwork for concrete pours with speed that suggested years of practice. Welders joined structural steel with techniques learned in shipyards and steel mills, not military training camps. These were not soldiers who had been taught construction. These were construction workers who had been taught soldiering. The distinction was profound. German military engineering units consisted of soldiers trained in basic construction skills. They could build field fortifications, repair roads, and perform essential military engineering tasks. But they lacked the deep, specialized knowledge that came from years in civilian trades. A German pioneer could operate a bulldozer. A Seabee operator had been pushing earth for 2 decades before the war started. Schneider made notes in a small diary he had been permitted to keep, documenting the construction techniques and equipment capacities he observed. He calculated that the American construction battalions possessed earth-moving capacity equivalent to 10 German pioneer companies. Their concrete production capability exceeded anything Schneider had seen on Luftwaffe construction projects in Europe. The speed of work suggested productivity rates 2 to 3 times higher than German military construction achieved. When Schneider's notes were discovered decades later among family papers donated to the Bundesarchiv in Freiburg, they included this assessment written on March 18, 1943. If the Americans can project this level of industrial capacity across the Pacific, if they can build airfields faster than we can bomb them, if they can sustain such operations simultaneously at multiple locations, then the strategic balance cannot favor Germany. We have assumed that distance and logistics would protect our conquests. The Americans have solved the problem of distance by bringing their industry with them. This changes everything. Schneider was witnessing what American strategic planners had recognized as the key to victory in the Pacific. Japanese forces could conquer territory, but they could not develop it rapidly enough to consolidate their gains. American forces could convert captured territory into operational bases faster than Japanese forces could mount effective counterattacks. This temporal advantage, measured in days and weeks, created an unstoppable momentum that no amount of Japanese courage or tactical skill could overcome. The Pacific theater presented unique challenges for military construction. Unlike Europe, with its existing road networks, rail lines, ports, and infrastructure, Pacific islands often possessed nothing but jungle, coral beaches, and perhaps a few primitive paths. Airfields had to be carved from jungle or built on coral. Harbours had to be dredged from shallow lagoons. Roads had to be pushed through terrain that vehicles could not otherwise traverse. Every element of military infrastructure required construction from raw materials in hostile environments. The distances involved magnified every logistical challenge. Guadalcanal lay 5,000 miles from San Francisco. Every bulldozer blade, every bag of cement, every welding rod, every spare part had to be transported by ship across an ocean contested by Japanese submarines. The supply chain from American factories to Pacific Island construction sites represented a logistical achievement as significant as the construction work itself. Admiral Raymond Spruance, commenting on Pacific strategy in a post-war interview preserved at the Naval War College, explained the centrality of construction capability. Island hopping succeeded because we could develop islands faster than the Japanese could reinforce them. We would seize an island, and within 2 weeks the Seabees would have an operational airfield. Within a month, that island would support air operations that neutralized enemy bases within a 300-mile radius. Within 2 months, we would be using it as a staging base for the next operation. The Japanese couldn't match that pace. They would fight heroically for an island, lose it, and watch helplessly as we converted it into a base that threatened their remaining positions. The Seabees gave us the tempo that won the war in the Pacific. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The strategic impact of Seabee construction capability extended beyond individual airfields. The ability to build bases rapidly enabled a form of warfare that the Japanese could not counter. American forces could bypass heavily fortified Japanese positions, seize lightly defended islands, and develop them into bases that rendered the bypassed positions irrelevant. Japanese garrisons on islands cut off from supply and reinforcement could neither attack American positions nor defend effectively when Americans finally chose to assault them. They simply withered on islands that became strategic backwaters. The Seabees built more than airfields. They constructed harbours from coral atolls, turning shallow lagoons into anchorages that could shelter entire fleets. They built roads through jungles and across mountains, creating supply lines where none had existed. They erected tank farms, ammunition dumps, hospitals, warehouses, and repair facilities. They installed electrical systems, water purification plants, and communications networks. They built the infrastructure of modern warfare in places where indigenous populations still lived in conditions barely changed from the Stone Age. The scale of construction in the Pacific theater staggers comprehension even today. Between 1942 and 1945, Seabee Battalions built or improved over 400 airfields, constructed 111 naval bases, and created thousands of miles of roads. They moved more than 300 million cubic yards of earth, poured over 20 million cubic yards of concrete, and erected structures containing over 7 million tons of steel. All of this was accomplished in tropical heat, under enemy fire, while battling disease and across distances that would have paralyzed less capable organizations. The Seabees' motto, "Can Do," reflected not bravado but a pragmatic assessment of capability. When told a project was impossible, Seabees responded by calculating how long the impossible would take and what equipment it would require. The phrase appears repeatedly in Seabee war diaries and official records, always in contexts where conventional military units would have requested delays, reinforcements, or alternative plans. Seabee battalions received impossible assignments and delivered completed projects ahead of schedule. This capability rested on several factors that German military engineers could not replicate. First, the Seabees possessed equipment superior in quantity and quality to Axis military construction units. American industry produced construction equipment in overwhelming numbers. A single Seabee Battalion possessed more bulldozers than an entire German pioneer division. The equipment itself represented the latest civilian technology, machines designed for maximum productivity in harsh conditions by companies like Caterpillar that had decades of experience building earth-moving equipment for mining operations, dam construction, and highway projects. Second, the Seabees benefited from American industrial standardization and mass production. Equipment parts were interchangeable between machines. Repair techniques were standardized. Every Seabee battalion included trained mechanics who could rebuild engines, fabricate replacement parts, and keep equipment operational far from repair depots. This contrasted sharply with German practice, where equipment came from multiple manufacturers with different specifications, making field repairs difficult and spare parts supply nightmarish. Third, the Seabees employed construction techniques optimized for speed rather than permanence. They understood that a runway built 70% as well as textbook specifications, but completed in 1/3, the time was far more valuable than a perfect runway that took months to build. They used coral as base material rather than importing gravel. They built with locally sourced timber when steel was unavailable. They improvised, adapted, and overcame obstacles with practical solutions rather than waiting for ideal materials and conditions. Fourth, and most critically, the Seabees possessed intrinsic motivation that conscripted German pioneers lacked. Many Seabees had volunteered specifically to use their civilian skills in military service. They took professional pride in their work, competing informally between battalions to see who could build faster or overcome more challenging conditions. German pioneers were soldiers performing assigned duties. Seabees were craftsmen building projects that would be judged by professional standards they had internalized over decades in civilian trades. The 10th Naval Construction Battalion's experience on Munda Point, New Georgia, illustrated these advantages with stark clarity. In July 1943, American forces invaded New Georgia to seize Munda Airfield, a Japanese installation that threatened Allied operations in the Solomons. The Japanese had fortified Munda heavily, and the ground campaign devolved into a brutal month-long fight through jungle against determined defenders. On August 5, 1943, American forces finally captured what remained of Munda Airfield. Japanese demolitions had destroyed virtually all above-ground facilities. Bomb craters pocked the runway. The jungle was reclaiming the cleared areas. The 10th Naval Construction Battalion landed on August 6 with orders to have Munda operational within 2 weeks. The battalion confronted destroyed infrastructure, unexploded ordnance scattered across the construction site, ongoing Japanese artillery fire from positions still holding out in the jungle, and tropical weather that alternated between scorching heat and torrential downpours. The battalion commander, Commander Wilbur Gulbranson, surveyed the site and radioed back a single word: "Can do." The 10th Battalion divided into teams that worked simultaneously on multiple aspects of the airfield reconstruction. One team cleared unexploded ordnance and filled bomb craters. Another team graded and compacted the runway surface. A third team constructed revetments and taxiways. A fourth team built fuel storage facilities and operations buildings. Equipment operated around the clock in 2 12-hour shifts. Men worked in tropical heat that caused heat exhaustion at appalling rates. On August 14th, 9 days after capture, the first American aircraft landed at Munda. The runway was operational, though not complete. Fighter aircraft could use it to refuel and rearm between missions. Within 2 weeks, Munda was handling over 100 aircraft operations daily. Within a month, it had become a major forward operating base, supporting further advances up the Solomon chain. The Japanese had spent 6 months building Munda. The Seabees rebuilt it in 9 days while under fire. German intelligence officers studying the Solomons campaign recognized the implications. A captured German military intelligence report dated September 1943, discovered in Wehrmacht archives after the war, analyzed American construction capabilities in the Pacific. The report, marked secret and addressed to the operations staff of the Armed Forces High Command, stated, "American military construction units demonstrate capabilities far exceeding any force Germany can deploy." Their construction battalions possess industrial-scale equipment and technical expertise that renders traditional military engineering obsolete. They can create operational airfields on captured territory within days rather than months. They sustain construction operations under combat conditions that would halt conventional pioneer units. Most critically, they operate simultaneously at multiple locations across the Pacific theater, demonstrating industrial capacity that Germany cannot match. If similar capabilities can be projected in the European theater, our fortification strategy may prove inadequate. In 1944, Seabee battalions would participate in the Normandy invasion, bringing to Europe the same capabilities that were transforming the Pacific War. But in 1943, the primary focus remained the island campaigns where Seabee contributions were most visible and most critical to American strategy. The Central Pacific Campaign, beginning in November 1943 with Operation Galvanic, the invasion of Tarawa and Makin atolls, would test Seabee capabilities under the most extreme conditions yet encountered. Tarawa, a coral atoll in the Gilbert Islands, contained Baitio Island where Japanese forces had constructed a heavily fortified airbase. The Japanese garrison of nearly 5,000 troops defended Baitio with concrete bunkers, extensive minefields, beach obstacles, and artillery positions designed to slaughter any amphibious assault. The Marines, who landed on November 20, 1943, encountered a killing ground. The three-day battle for Baitio became one of the bloodiest in Marine Corps history, with over 3,000 Marine casualties. When the fighting ended on November 23, the Marines had seized an island so devastated that it resembled photographs of First World War battlefields. The 2nd and 18th Naval Construction Battalions landed on Baitio before combat operations had completely ceased. Japanese snipers still held positions in rubble. Unexploded ordnance contaminated every square yard of the island. The stench of death hung over Baitio like a physical presence. The Seabees were ordered to rebuild the captured Japanese airfield and make it operational within 72 hours. The assignment appeared impossible. The airfield had sustained severe damage from American naval bombardment and airstrikes. Bomb craters intersected so densely in places that the original runway surface had essentially ceased to exist. Japanese had demolished facilities before their final positions were overrun. No fresh water was available on the island. Supply ships could not approach the beach due to coral reefs that had torn apart many landing craft during the assault. Every ton of material had to be transferred from ship to shore by small boat or amphibious vehicle. The 2nd Battalion's commander, Commander Joseph O'Leary, established his command post in a shattered Japanese bunker and began organizing the reconstruction. Bulldozers were unloaded directly onto the reef and drove through shallow water to reach the beach. Equipment that couldn't drive through water was lifted by cranes operating from landing craft grounded on the reef. Within hours, bulldozers were pushing rubble and filling craters. By nightfall November 23, 12 hours after landing, the battalion had cleared a path through obstacles and begun runway reconstruction. The work proceeded with urgency, driven by strategic necessity. American forces planned to use Tarawa as a base for strikes against Japanese positions in the Marshall Islands. Every day without an operational airfield delayed these operations and gave Japanese forces time to reinforce their defenses. The Seabees worked through the night under portable lights powered by generators. Japanese air raids struck twice during the first night, killing 4 Seabees and wounding 11 others. The survivors resumed work as soon as the all-clear sounded. On November 26th, 72 hours after landing, the first American bomber landed at Tarawa. The pilot later reported that the runway surface was rough and the facilities primitive, but the airfield was functional. Within a week, Tarawa was launching strikes against Japanese positions 500 miles distant. Within 2 weeks, it had become a major staging base for Operation Flintlock, the invasion of the Marshall Islands scheduled for February 1944. The speed of reconstruction at Tarawa impressed even American commanders familiar with Seabee capabilities. Admiral Chester Nimitz, Commander-in-Chief Pacific Fleet, visited Tarawa in December 1943 and toured the reconstructed airbase. His report to the Navy Department, preserved in National Archives, noted, "The transformation of Betio from a demolished battlefield to an operational airbase in less than 2 weeks represents an achievement without parallel in military history. The construction battalions have proven themselves indispensable to our Pacific strategy. No other force can provide the rapid base development capability that our island-hopping campaign requires. I recommend maximum priority be given to Seabee deployment and equipment allocation. The Marshall Islands campaign in early 1944 demonstrated the full maturity of Seabee capabilities and doctrine. Operation Flintlock, launched on January 31, 1944, targeted Kwajalein Atoll, the largest coral atoll in the world. The operation would become a showcase for American amphibious doctrine, with Seabee construction playing a central role in the rapid development of captured territory. Kwajalein Atoll contains over 90 islands surrounding a massive lagoon 20 miles wide and 60 miles long. The Japanese had fortified several key islands, with the heaviest defences on Kwajalein Island at the southern end of the atoll and Roy Namur at the northern end. American planners divided the operation into 2 simultaneous assaults. The Army's 7th Infantry Division would seize Kwajalein Island, while the 4th Marine Division assaulted Roy Namur. The Seabees assigned to support these operations included the 18th Naval Construction Battalion supporting the Marines at Roy Namur, and the 77th Naval Construction Battalion supporting the Army at Kwajalein Island. Both battalions would land immediately behind the assault waves, beginning construction work while combat operations continued. This represented evolution in doctrine from earlier operations, where Seabees waited until islands were secured before beginning major construction. The assault on Roy Namur began on February 1, 1944, following the most intensive naval and aerial bombardment yet delivered in support of a Pacific landing. The Marines fought through Japanese defences and secured both islands by February 2. The 18th Naval Construction Battalion landed on Roai Island on February 1, even as Marines were still clearing Japanese positions on adjacent Namur. The battalion's immediate mission was to repair and extend the Japanese-built airfield on Ro. The Japanese had constructed 2 intersecting runways, forming an X pattern on the narrow island. American bombardment had cratered both runways and destroyed all above-ground facilities. The 18th Battalion began work within hours of landing, operating under sporadic fire from Japanese holdouts who had retreated into underground positions. The pace of reconstruction exceeded even the ambitious plans that preceded the operation. By February 3, 48 hours after landing, the 18th Battalion had repaired 1 runway sufficiently for emergency landings. By February 5, regular flight operations commenced. By February 7, the airfield was handling over 100 aircraft operations daily and serving as a forward base for strikes against Japanese positions in the Marshall Islands, still holding out. The 77th Naval Construction Battalion at Kwajalein Island achieved similar results under different conditions. Kwajalein Island, larger than Roy but narrower, had sustained even heavier bombardment than Roy Namur. The 7th Infantry Division fought for 4 days to secure the island against fanatical Japanese resistance. The 77th Battalion landed on February 2 and immediately confronted challenges that tested every aspect of Seabee training and improvisation skills. The Japanese airfield on Kwajalein had been virtually obliterated by American bombardment. Craters overlapped so densely that determining the original runway alignment required careful surveying. Underground fuel storage tanks had been ruptured, contaminating soil with aviation gasoline. Unexploded American ordnance littered the construction area. Japanese defenders in bypassed positions occasionally emerged to attack work parties. Commander Robert Taylor, commanding the 77th Battalion, organized his unit into 4 work sections operating simultaneously. One section cleared unexploded ordnance and filled bomb craters. A second section surveyed and graded the runway alignment. A third section constructed a new runway surface using crushed coral. A fourth section built taxiways, revetments, and support facilities. The work proceeded continuously, with shifts rotating through 24-hour periods. The battalion encountered a problem that threatened to delay runway completion. The coral available on Kwajalein was softer than ideal for runway construction, prone to breaking down under heavy aircraft traffic. Standard procedure would require importing harder coral or crushed stone, a process that would delay completion by weeks. Commander Taylor consulted with the battalion's geologist, Lieutenant Robert Ferguson, who had worked in mining before the war. Ferguson conducted rapid field tests of coral from different locations on the island and from the lagoon. He discovered that coral from the lagoon, when crushed and mixed with a small percentage of cement, created a material superior to the island coral. The lagoon coral had been subjected to continuous wave action that had hardened it naturally. Mixed with cement in a 5% ratio, it formed a surface that could support heavy bombers. The battalion immediately shifted operations to dredging lagoon coral. Amphibious vehicles brought coral from offshore deposits. Crushers reduced it to proper size. Concrete mixers added the cement binder. The mixture was spread, graded, and compacted. On February 11th, 9 days after landing, the first bombers landed at Kwajalein. By February 15th, Kwajalein was operating as a major bomber base supporting operations throughout the Marshall Islands. The Marshall Islands campaign provided the first comprehensive assessment of Seabee impact on Pacific operations. Admiral Nimitz commissioned a study analyzing the time required to develop captured islands into operational bases. The study, completed in March 1944 and preserved in Navy archives, compared development timelines across multiple operations. At Guadalcanal, 6 months elapsed between initial capture and full airfield operations. At Tarawa, 3 weeks. At Roy Namur, 1 week. At Kwajalein, 9 days. The acceleration was not due to less severe damage or easier conditions. Kwajalein and Roy Namur had sustained heavier damage than Guadalcanal. The improvement reflected accumulated Seabee experience, refined procedures, better equipment, and organizational improvements that came from analyzing each operation and implementing lessons learned. The Seabees were becoming more efficient with each successive campaign. German intelligence monitoring Pacific operations recognized that American construction capabilities represented a form of military power they could not match. A lengthy intelligence assessment produced by the Oberkommando der Wehrmacht in April 1944, captured by American forces in 1945 and subsequently translated, analyzed American construction battalions in detail. The report ran to 47 pages and represented the most comprehensive German study of Seabee operations. The introduction to the report stated its conclusions with unusual bluntness. The United States has developed a military construction capability that transforms the strategic equation of Pacific warfare. Their construction battalions possess equipment, technical expertise, and organizational methods that enable them to build military infrastructure at speeds previously considered impossible. They can convert captured territory into operational bases within days, creating a tempo of operations that Japanese forces cannot counter. Germany possesses no equivalent capability and cannot develop one given current industrial conditions. If similar construction units are deployed in the European theatre, they will enable Allied operations that our current defensive strategies cannot prevent. The report analyzed specific Seabee operations in detail, using intelligence gathered from multiple sources, including aerial reconnaissance photographs, intercepted communications, reports from neutral observers, and interrogations of captured American prisoners. The analysis focused on equipment capabilities, organizational structure, construction techniques, and the integration of construction operations with combat operations. One section of the report examined Seabee equipment in exhaustive detail, listing the types and quantities of machinery typical in a construction battalion, estimating production rates for earth-moving and concrete work, and comparing American construction equipment to German equivalents. The German analysts calculated that a single American construction battalion possessed earth-moving capacity equivalent to 15 German pioneer companies and concrete production capability exceeding anything available to the Wehrmacht. Outside of Organization TOT, the massive civil engineering group that built the Atlantic Wall fortifications. Another section analyzed construction techniques, noting with what German engineers clearly considered grudging admiration the American preference for speed over perfection. The report stated, American construction methods prioritize rapid completion over structural excellence. They build adequately rather than perfectly, accepting 70% solutions that can be implemented in one-third the time required for optimal solutions. This pragmatic approach produces infrastructure that meets military requirements without the delays inherent in German engineering standards. In rapid operations where time is the critical factor, their methods prove superior despite technical compromises. The report's most significant section addressed strategic implications. The analysts recognized that Seabee capabilities enabled a form of warfare that Germany could not effectively counter. American strategy in the Pacific depends on the ability to seize lightly defended territory and develop it into operational bases faster than Japanese forces can mount effective counterattacks. The tempo of American operations is dictated not by combat capability, but by construction capability. They can build bases faster than the enemy can destroy them, creating an operational pace that overwhelms defensive responses. This represents a fundamental change in the nature of warfare, where industrial capacity projected across strategic distances becomes decisive. Germany's defensive strategy in the East and West assumes that Allied forces will be constrained by logistical limitations and infrastructure requirements. American construction battalions remove these constraints, enabling operations at scales and speeds that exceed German defensive planning assumptions. The report concluded with a recommendation that was never implemented. Germany should immediately establish military construction units comparable to American construction battalions, recruiting skilled workers from essential industries and organizing them into mobile construction formations equipped with modern machinery. These units would strengthen defensive positions in the East and West, accelerate construction of fortifications, and maintain critical infrastructure under air attack. However, Germany lacks the industrial capacity to equip such units adequately and cannot spare skilled workers from war production. The recommendation is therefore impractical under current conditions. The German High Command filed the report without taking action on its recommendations. Germany, in mid-1944, was fighting for survival on multiple fronts. Resources that might have been devoted to developing construction capabilities were instead directed to producing tanks, aircraft, and ammunition for desperate defensive battles. The opportunity to create German equivalents to the Seabees, if such opportunity had ever existed, had passed. In June 1944, Seabees participated in operations that brought their capabilities to the European theatre. The Normandy invasion, Operation Overlord, required engineering support on a scale that dwarfed Pacific operations. The invasion plan called for landing over 150,000 troops on 5 beaches in occupied France, then sustaining them through a campaign that would liberate Western Europe. The logistics of such an operation demanded construction capabilities that only the Seabees could provide. 6 naval construction battalions participated in the Normandy invasion, landing on the beaches alongside Army combat engineers. Their mission was to clear beach obstacles, build roads off the beaches, construct supply dumps, establish fuel distribution systems, and support the rapid build-up of forces ashore. The 1st Naval Construction Regiment, consisting of 3 battalions, landed on Omaha Beach on D-Day. The 11th Naval Construction Regiment, also 3 battalions, supported operations on Utah Beach. The conditions on Omaha Beach tested Seabee capabilities under the most extreme circumstances of the war. The beach assault encountered unexpectedly strong German resistance. Casualties among the first waves were catastrophic. The beach became congested with disabled vehicles, wounded men, and equipment that couldn't move inland due to German fire from positions overlooking the beach. The Seabees landing in later waves found themselves working under direct fire, while simultaneously dealing with wounded soldiers, disabled vehicles, and German artillery shells that fell continuously on the beach. The 32nd Naval Construction Battalion, part of the 1st Regiment, landed on Omaha Beach in the afternoon of June 6th. The battalion's equipment and supplies were scattered across multiple landing craft, many of which were damaged or sunk before reaching shore. Men came ashore carrying personal weapons, hand tools, and explosives. Heavy equipment that did reach the beach often bogged down in sand or was damaged by German fire. Despite these conditions, the battalion began clearing obstacles and improving beach exits. Combat engineers had blown gaps through the seawall during the morning assault. The Seabees widened these gaps, graded approaches to allow vehicles to pass, and began improving the roads leading inland. They worked under continuous German artillery fire, suffering casualties but maintaining operations. By nightfall, June 6th, vehicle traffic was moving off Omaha Beach through routes the Seabees had improved. Over subsequent days, as the beachhead expanded and German fire decreased, the Seabee Battalions transformed the beaches into massive logistics facilities. They built roads capable of handling the heaviest tanks. They constructed fuel pipelines from offshore tankers to inland supply points. They erected ammunition dumps, supply depots, and maintenance facilities. They improved the small Normandy port of Port-en-Bessin to handle coastal shipping. The scale of construction in Normandy exceeded anything attempted in the Pacific. Within 2 weeks of D-Day, the Normandy beachhead was handling cargo volumes that equaled the tonnage moved through the port of Dover, Britain's busiest cross-channel harbour. Within a month, the artificial harbours at Arromanches and the developed beaches were handling more tonnage than any port in Europe. The Seabees had projected American industrial capacity not just across an ocean, but onto a hostile shore, where every ton of material, every piece of equipment, and every gallon of fuel had to be fought ashore under fire. German commanders confronting the Normandy invasion recognized immediately that they faced an enemy with capabilities their defensive planning had not anticipated. Field Marshal Erwin Rommel, commanding Army Group B responsible for defending Normandy, wrote in his diary on June 15, 1944, an entry that was published posthumously in his collected papers. The Anglo-American ability to build up forces and supplies on open beaches exceeds all previous estimates. Their construction units work with industrial efficiency despite our artillery fire. They have created harbour facilities where none existed, supporting an invasion force that grows stronger daily. Our strategy depended on preventing the enemy from establishing a sustainable lodgment. That strategy has failed. The enemy's construction capability has proven equal to our defensive measures. Rommel's assessment reflected a broader realization spreading through the German High Command. The Wehrmacht had based its defensive strategy on assumptions about Allied limitations that were proving false. The Germans had assumed that distance would protect their conquests, that logistics would constrain Allied operations, that lack of ports would make invasion unsustainable. The Seabees, along with other American construction and logistics organizations, were systematically demolishing each assumption. In the Pacific, the tempo of American operations accelerated through 1944 and into 1945. The Marianas Campaign in summer 1944, the Philippines Campaign beginning in October 1944, and the final island assaults on Iwo Jima and Okinawa in 1945 all depended on Seabee capabilities. At each location, the pattern repeated. American forces would seize an island, Seabees would immediately begin construction, and within days or weeks, the captured territory would become an operational base supporting further advances. The invasion of Tinian in July 1944 provided perhaps the most dramatic example of Seabee capabilities at full maturity. Tinian, an island in the Marianas, was needed as a base for B-29 Superfortress bombers that would strike the Japanese home islands. The island contained Japanese airfields that American forces planned to capture and expand into major bomber bases. The 6th Naval Construction Brigade, consisting of multiple Seabee battalions, was assigned to develop Tinian's airfields. The brigade commander, Captain Donald Cooley, had reviewed the plans and determined that standard procedures would require months to complete the necessary construction. Tinian's airfields needed to accommodate the largest bombers in bombers, the American infantry operating at maximum takeoff weights. The runways would need to be longer, wider, and stronger than anything yet built in the Pacific. Cooley proposed an alternative approach. Rather than building one perfect airfield at a time, his battalions would work simultaneously on all 4 planned airfields, bringing each to minimal operational capacity before completing any to full specifications. This parallel construction method would provide operational airfields faster, even though full completion would take longer. Admiral Nimitz approved the plan. The Seabee Battalions landed on Tinian on July 24, 1944, immediately following the marine assault. Within 10 days, they had one airfield operational for fighter aircraft. Within 3 weeks, the first B-29 bomber landed at Tinian. Within 3 months, all 4 airfields were operational, and Tinian had become the busiest bomber base in the world. From Tinian, B-29 bombers launched the strategic bombing campaign against Japan that would ultimately include the atomic bomb missions. The Enola Gay and Bockscar, the aircraft that dropped atomic bombs on Hiroshima and Nagasaki, took off from runways the Seabees had built on Tinian. The entire strategic bombing campaign that brought Japan to surrender depended on airfields that had not existed 6 months earlier, built on an island that Japanese forces had controlled until July 1944. The statistics documenting Seabee contributions to the Pacific War demonstrate capabilities that no other nation matched during World War II. The Seabees built 111 major naval bases, 400 airfields of all sizes, and 7,000 other military facilities, including hospitals, warehouses, and communications installations. They constructed over 350 dock and harbour facilities and laid thousands of miles of roads, pipelines, and communication lines. They moved more than 300 million cubic yards of earth and placed over 20 million cubic yards of concrete. At peak deployment in 1945, over 300,000 men served in naval construction battalions operating across the Pacific, Caribbean, Atlantic, and Mediterranean theatres. The human cost was proportionate to the scope of operations. Over 2,500 Seabees died in World War II, with over 400 killed in action and the remainder dying from disease, accidents, and other causes related to service in combat zones. Over 7,000 were wounded. The casualty rates among construction units working in combat zones approached those of infantry units in some operations. The legacy of the Seabees extended beyond their wartime accomplishments. After World War II, naval construction battalions remained part of the U.S. military establishment, participating in the Korean War, Vietnam War, and subsequent conflicts. Seabee construction capabilities supported humanitarian relief operations, disaster response, and peacetime military construction projects around the world. The concept pioneered in 1942 that military construction required dedicated units with combat training and construction expertise became permanent doctrine. The German prisoners who witnessed Seabee operations in the Pacific carried memories that shaped their understanding of why Germany lost the war. After the war ended, Allied intelligence services interviewed thousands of German prisoners, collecting assessments of American military capabilities. A common theme in these interviews was German prisoners' surprise at American industrial capacity and engineering capabilities. One interview, conducted in September 1945 with a former Luftwaffe officer who had been captured in the Pacific, recorded observations remarkably similar to those Oberleutnant Schneider had written in his diary at Guadalcanal in 1943. The officer stated, "I had been taught that German engineering was superior, that German organization was more efficient, that German soldiers were better trained. Then I watched American construction units build an airfield in less time than German pioneers needed to repair a road. I watched their machines move earth at rates I had considered impossible. I watched their supply system deliver materials across thousands of miles of ocean, while German supply broke down moving materials a few hundred kilometers. I realized then that Germany could not win. We were fighting an enemy with industrial capacity so vast that our entire war economy was insignificant by comparison. They were not just stronger than us, they were playing a different game entirely." This recognition that American industrial capacity represented a form of military power that Germany could not match spread through the German officer corps as the war progressed. The sight of American construction battalions transforming captured territory into operational bases became symbolic of the overwhelming material superiority that defeated Germany. No amount of German tactical skill, no superiority in individual weapons, no fighting spirit could overcome an enemy that could project industrial capacity across oceans and continents. The strategic revolution the Seabees represented was fundamentally about time. In previous wars, armies moved at the pace of their logistics. Supply lines could only be extended as fast as roads could be built, ports could be captured, and infrastructure could be repaired. The Seabees changed this equation by accelerating infrastructure development to match the tempo of combat operations. American forces could advance as fast as they could fight, because the Seabees could build supply infrastructure as fast as combat units could seize territory. This capability transformed amphibious warfare. Before the Seabees, amphibious operations required capture of ports. After the Seabees, amphibious forces could land anywhere and build their own ports. The strategic flexibility this provided was revolutionary. German and Japanese defenses focused on protecting ports because military doctrine for centuries had taught that ports were essential. The Seabees made ports optional, rendering defensive strategies based on protecting them obsolete. The German officer corps, trained in traditional military doctrine, struggled to adapt to this new reality. They fortified what seemed important, concentrated defenses at obvious objectives, and assumed logistics would limit Allied operations. The Allies, with Seabee construction capability enabling unprecedented logistical flexibility, simply bypassed German strongpoints, seized lightly defended terrain, and built the infrastructure needed to sustain operations. By the time German commanders recognized what was happening, the strategic initiative had passed permanently to the Allies. Admiral Raymond Spruance, in his final report on Pacific operations submitted in October 1945, assessed the contribution of naval construction battalions to victory. The Seabees provided capabilities essential to every major operation in the Pacific theater. Their ability to build airfields rapidly enabled our island-hopping strategy. Their construction of naval bases provided fleet anchorages across the Pacific. Their engineering skills solved problems that would have halted operations conducted by conventional forces. Without the Seabees, the Pacific War would have lasted years longer and cost tens of thousands of additional lives. The construction battalions represent one of the most significant military innovations of the war. For Oberleutnant Karl Schneider, the German pilot who watched Seabees work at Guadalcanal in March 1943, the memory of those 3 days remained vivid for the rest of his life. He spent the remainder of the war in a prisoner of war camp in the United States, was repatriated to Germany in 1946, and worked as a civil engineer in post-war West Germany. In 1978, he was interviewed for an oral history project documenting German veterans' experiences. The interviewer asked what moment in the war made him realize Germany would lose. Schneider's response, preserved in the oral history archives, went back to those 3 days at Guadalcanal. I stood on that island and watched American construction workers in Navy uniforms build an airfield faster than I believed possible. They had equipment we could not match, skills we could not replicate, and an organizational system we could not duplicate. But more than that, they had abundance. They wasted materials because they had so many materials that waste didn't matter. They discarded equipment that broke rather than repairing it because they had new equipment arriving constantly. They approached problems with the confidence of people who knew they had unlimited resources behind them. That is when I knew. Germany was fighting a war of scarcity. We hoarded every liter of fuel, conserved every round of ammunition, repaired every broken machine because we had no replacements. America was fighting a war of abundance. They could afford to waste because they produced so much that waste was irrelevant. You cannot defeat abundance with efficiency. You cannot overcome industrial capacity with tactics. Germany lost the war at Guadalcanal, even though the battles continued for 2 more years. We just didn't know it yet. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.